So hello guys, welcome back to my YouTube channel. Today we will see numerical solving session of a new chapter, current electricity. Let's look at the first sum. A battery of EMF 4 volt and internal resistance 1 ohm is connected in parallel with another battery of EMF 1 volt and internal resistance 1 ohm with the like poles connected together. The combination is used to send current through an external resistance of 2 ohms. Calculate the current through the external resistance. So first of all, let's draw the circuit based on the given condition. Now based on the given condition, our circuit will look like this. Two EMFs of 4 volt and 1 volt connected in parallel with an external resistance of 2 ohms, and we need to find out the current which is passing through the external resistance, which is our I1. Now if you apply KCL here at this point, you will know that current I is splitting into I1 and I2. So we can say that from KCL at point B, I equal to I1 plus I2. Now let's name it at equation 1. Now in order to evaluate I1, we need to apply KVL. So before applying KVL, we need to know some of the rules. So first of all, if you are moving from higher potential to lower potential for a cell, you will take the sign as negative, and if you are moving from lower to higher, then you will take the sign as positive. Similarly, if your current direction is on right hand side and your loop direction is also on right hand side, then while passing through the resistance, you will take the value of the potential across the resistor as negative. But if the current is flowing in opposite direction to the direction of your loop, you will take the value of potential to be positive. I hope you understood this rules. Now let's apply KVL. So first of all, let's apply KVL on loop B C D E B. You can apply the loop in clockwise or anti-clockwise, it won't matter. Answer will come same only. So when you apply KVL at loop B C D E B, you get I2 plus 1 minus 2 I1. That is I2 plus 1 minus 2 I1 equal to 0, which implies 2 I1 minus I2 equal to 1. Let's name it at equation 2. Now again applying KVL at loop ABEFA, that is here. So which will give you 4 minus 1 minus I2 minus I equal to 0, which implies I plus I2 equal to 3. Now we know that I is nothing but I1 plus I2, which implies this will become I1 plus 2I2 equal to 3. Let's name it at equation 3. Now by solving these two equations simultaneously, you can get the value of I1. So in order to get I1, you need to cancel out I2. So if you will multiply the equation 2 with 2, you will get 4I1 minus 2I2 equal to 2. Now if you will add these two equations, you will get 4I1 minus 2I2 equal to 2 plus I1 plus 2I2 equal to 3. Now these two will get cancelled and this will become 5I1 equal to 2 plus 3, 5, which implies our I1 is 1 ampere. So we found out the current which is flowing from our external resistance 2 ohms, which is equal to 1 ampere. I hope you understood this sum. Let's look at the next sum. Two cells of EMF 1.5 volts and 2 volts having respective internal resistance of 1 ohm and 2 ohm are connected in parallel so as to send current in same direction through an external resistance of 5 ohms. Find the current through the external resistance. So same thing, we need to first draw the circuit diagram based on the given condition. Now the circuit diagram comes out to be this. So let's apply KVL here also. So here we need to find out the current through the external resistance. Now as you can see, again the current that is flowing through the external resistance is I1. So essentially we need to find out the value of I1. Now from KCL we know that I is our I1 plus I2. So I is only I1 plus I2. So applying KVL at loop BCDEB based on the previous rule that I explained you, we get minus 5 I1 plus 2 I2 plus 2 equal to 0. Now rearranging it, we get 5 I1 minus 2 I2 equal to 2. Let's name it at equation 1. Now again applying KVL at the bigger loop A B C D E F. A. I am saying that you can apply the loop at here also. It won't matter, the answer that you will get will be similar only. You can apply the loop clockwise also or anti-clockwise also. Okay. Here I have applied the loop anti-clockwise. So we will get 1.5 minus 5 I1 minus I equal to 0. Now putting the value of I here, which is I1 plus I2, we get 1.5 minus 5 I1 minus I2 equal to 0, which will get 1.5 minus 6 I1 minus I2 equal to 0. Now rearranging it, we will get 6 I1 plus I2 equal to 1.5. Let's name it at equation 2. Now in order to find out I1, you need to remove I2. So if you multiply this equation 2 with 2, you will get this as 12 I1 plus 2 I2 plus 3. Now let's add these two equations. So 12 I1 plus 2 I2 equal to 3 plus 5 I1 minus 2 I2 equal to 2. So 12 plus 5 is 17 I1, and these two will get cancelled, which is equal to 5. Now I1 will be 5 by 17 ampere. So the current flowing through the external resistance of 5 ohms is 5 by 17 amperes. Let's look at the next sum. A voltmeter has a resistance 30 ohms. What will be its reading when it is connected across a cell of EMF 2 volts having internal resistance 10 ohms? So let's see what we have been given. We have been given R equal to 30 ohms and the EMF equal to 2 volts, which is having an internal resistance of 10 ohms, and we need to find out the value of the voltage that the voltmeter will show. So we know the formula V equal to E R upon R plus R, correct? So let's put the value, which will be 2 into 30 divided by 30 plus 10, which is 60 by 40, which is nothing but this 2 get cancelled, 2 2s are 2 3s are 1.5 volt. So the voltmeter will show the reading V equal to 1.5 volts. Pretty easy sum. Let's look at the next sum. A set of 3 coils having resistance 10 ohms, 12 ohms and 15 ohms are connected in parallel. This combination is connected in series with series combination of 3 coils of the same resistance. Calculate the total resistance and current through the circuit if a battery of EMF 4.1 volt is used for drawing current. So let's first of all draw the circuit diagram. So based on the given condition, our circuit diagram looks like this. 3 resistors are connected in parallel and their combination is connected with series with 3 more resistors of 10 ohms and 12 ohms and 15 ohms. Okay. So if you look carefully, if you find out this 3 resistance, the equivalent resistance will be Rp, and if you will find out the equivalent resistance of this series combination, this will give you Rs, and the total resistance that we need to calculate in the circuit will be R, which is equal to Rp plus Rs. So in order to calculate Rp plus Rs, we know the formula for parallel combination, that is 1 upon Rp equal to 1 upon 10 plus 1 upon 12 plus 1 upon 15, that is these 3 resistance value. This will give you 6 plus 5 plus 4 divided by 60, which is 15 by 60, which is equal to 15 ones are 15, 4s are 1 by 4. So 1 by Rp is 1 by 4, which implies Rp is equal to 4 ohms. Similarly, for series combination we know Rs equal to 10 plus 12 plus 15, which is equal to 37 ohms. So Rs is 37 ohms. Now the total resistance of the circuit will be Rp plus Rs, which is equal to 4 plus 37, which is 41 ohms. So the total resistance in this given circuit is 41 ohms. Now we also need to calculate the current in the circuit. So we know from Ohm's law that I equal to V by R. So the voltage that is given to us is 4.1 volts and resistance that we got here is 41 ohms. Now as you can clearly see, this is 1 by 10, which implies 0.1 ampere. So the current I is 0.1 ampere. Let's look at the next sum. A potentiometer wire has a length of 1.5 meter and resistance of 10 ohms. It is connected in series with a cell of EMF 4 volt and internal resistance of 5 ohms. Calculate the potential drop per unit centimeter of the wire. So we need to calculate the value of potential gradient, that is K. So the things that are given to us is length, which is equal to 1.5 meter. Now as you can see, we need to calculate the potential drop per centimeter of the wire. So let's convert this length into centimeter, which will give you 150 centimeters. Now the resistance that is given to us is 10 ohms and the EMF is 4 volt and the internal resistance is 5 ohms. So based on this, the value K is V by L. Now we know V is E R upon R plus R into L in the denominator. Now let's substitute the value, which will be 4 into 10 divided by R is 10 plus small r is 5 into L is 150. So this to get cancelled, 10 into 5 15, 15 15 is 225, right? And above is 4, so 4 divided by 225 is 0.0177 volt per centimeter. So remember the unit that they needed the answer in. So now let's look at the next sum. When two cells of EMF E1 and E2 are connected in series so as to assist each other, the balancing length on potentiometer is found to be 2.7 meter. When the cells are connected in series so as to oppose each other, the balancing length is found to be 0.3 meters. Compare the EMF of the two cells. So solution. So here we need to compare the EMF of the two cells. We can do this by using the sum and difference method. Now according to the given condition, when the cells are connected in series to assist each other, the balancing length on potentiometer is 2.7 meter, which implies that when they are assisting each other, that is E1 plus E2 will give you K times L1. Now L1 is 2.7 meter. And when the cells are connected in series so as to oppose each other, that is E1 minus E2 equal to K times the balancing length is found to be 0.3 meter. Let's take it as L2. Now let's take the ratio, which implies E1 plus E2 divided by E1 minus E2 equal to L1 upon L2. Now applying componendo dividendo, we get E1 upon E2 equal to L1 plus L2 upon L1 minus L2. Now let's substitute the value of L1 and L2. L1 is 2.7 meter plus L2 is 0.3 meter divided by 2.7 minus 0.3, which is equal to 3 upon 2.4. This can be written as 30 by 24. Now cancelling it, 3 8s are 3 10s are 2 4s are 2 5s are, and 5 divided by 4 is 1.25. So the ratio of the two EMF, that is E1 upon E2, is 1.25. I hope you understood the sums that we did today. The part 2 of this chapter's numerical will come very soon. Thank you for watching this video, and if you liked this video, please like, share and subscribe, and comment your valuable feedback so as to improve the content on this channel.